Hey guys, in today's video, I am going to explain my KKBox Churn Prediction project in PySpark. So, if you're watching this video, I must have uploaded a video about how to implement churn prediction. If you haven't watched my last video, I will give an introduction to the project. This project predicts customer churn for a music streaming platform and it's subscription based like Spotify. The data is available on Kaggle and they have millions of user logs. So my goal was to identify retention strategies and make business recommendations and build this into a case study for my portfolio. When I did this project at first using pandas, my unique challenge was that the data set is too big and I had to do chunking in pandas, do aggregation, which actually led to a serious problem, which I'll explain. So I built a PySpark pipeline for the same project. In this PySpark version, I'm not going deep into EDA, experimentation, and analysis because I did that in the previous project. This project's goal is to demonstrate the best practices using PySpark and why PySpark is superior than pandas when you're dealing with big data. This video is for people who already know a little bit of pandas, ML, and are new to PySpark. What is PySpark and why do we need to learn PySpark if we work in data science? Think of it as a tool for scaling up your data science workflows, while Pandas is designed for single mission in memory data processing. PySpark is built for distributed computing. It's for massive data sets that do not fit in your computer's memory. So usually pandas operate on a single mission and pandas load the entire data set into your RAM when you run the code for pd.read csv or whatever format of data that you are using. It just loads the entire data set into your RAM. This makes pandas much faster and it's flexible for smaller data sets, prototypes, before building a production model. PySpark work across a cluster of machines. It splits large chunks of data into smaller chunks, which is what we did in our KKBox Churn Prediction project using Pandas itself. We did it manually. In PySpark, these chunks are called partitions. PySpark distributes them for parallel processing, allows it to process data that's in terabytes or sometimes petabytes. Also, PySpark execution method is lazy, where Pandas execution method is eager. So lazy means think of it like this: you have a to-do list, and if you work if your method of execution is eager, you will be completing each task as you write it down on the to-do list. Where if your method of execution is lazy, you will write down all the tasks at once and then do everything at the end. So in PySpark, when you load your data, you have to start a Spark session, which is essentially the entry point for all PySpark functionality. Like Pandas, PySpark has different methods to load data. Like if you already know Pandas, it's super easy to pick up PySpark. For example, in Pandas, when we print the first 5 rows using the df.head function, PySpark uses df.show. The syntax is kind of same. If you know pandas, you can easily learn PySpark. Also, instead of scikit-learn, PySpark has something called mlib. So mlib provides scalable algorithms and ML pipelines that are well suited for distributed data. So in high-level concepts, the API is pretty much similar to scikit-learn, but The difference is in the way that it handles large amount of data seamlessly using distributed computing. PySpark is actually a Python interface for Apache Spark, which is an open source distributed computing system, and it enables data scientists, machine learning engineers, and ML scientists to enable batch processing, real time computing, um, data analytics, machine learning on big data. And a Spark cluster is a group of computers. So in a distributed architecture, there will be a master node and a bunch of worker nodes. A cluster is a group of computers that collaboratively process large-scale data using Apache Spark. Master node usually handles all the resource allocation and stuff, and the workers will do the processing. I learned PySpark the first time from a data chem course. There's a course called Introduction to PySpark. Then there are a bunch of courses. I think it's available on their YouTube channel as a long 6-hour video. Um, I'll link the I'll link I'll link the video in the description. It's a really good start. Then just do a project, and when you feel stuck, go and learn the go and learn something. Whenever you do a project, always like understand why this tool and why this particular process is. So let's so if you do that course, you'll get an introduction to PySpark. Then so in my churn prediction using PySpark, I gave importance to extracting a lot of temporal features rather than aggregating my data at first. When I did the project with pandas, I had to aggregate the data. The logs were too big for pandas, so I aggregated at the start, but I missed one thing. So in churn prediction, you will be predicting the churn usually for the last 30 days, and you should set a cutoff range for that data, even though you are aggregating, because that would lead to data leakage. What I did is I aggregated the whole data set, and I just ran prediction using XGBoost and predicted the values, and the accuracy was good, but there is a chance for data leakage because since I'm using the last 30 days of data as my test data, um, the aggregated values have already seen the aggregated data has already seen the last 30. I'm doing this project on collab on a single node, but this can be scaled to a distributed multi-cloud, multi-node architecture. In my original string churn prediction project, I aggregated the data using serial number, member serial number. Actually, churn is about behavior over time. So just taking the totals does not really do justice to the data that we have. We're kind of not using the most important feature from our data set. So we use temporal features like recency, momentum, consistency, um, mixed shelves, seasonality, things like that. When we aggregate the data, we can aggregate weekly, daily, or monthly. Daily is sweet spot, but it might take a lot of compute and it might take a lot of time. So weekly is all okay. Monthly is also okay. And like I said about data leakage, in my original project, I had um, transactions until March, and I should have been left march out for prediction, which I did not do during aggregations, which might have led to data leakage. So, when should you start using something like PySpark? Pandas is okay for up to a few million rows, say data that fits in 2 to 5 GB RAM. Beyond that, Pandas usually crashes or it slows down the whole pipeline. So less than 1 to 2 GB, Pandas is Pandas works fine. So if your data is between 2 to 10 GB, Pandas might be a little bit slow. So using Spark might help. 10 plus GB or billions of rows, Spark is the right tool to process your data. So, in production environments where we process transactions, streaming data sets, clickstream data, uh, with millions of billions of rows, Spark shines really well. In Pandas, you code line by line. So filter, group, join. But in PySpark, Spark waits until the end to actually run things. It builds a plan of all the steps first. So the plan is called a DAG or directed acyclic graph. In Pandas, when you do something like a group by or a merge, all the data is there in your memory on your laptop. In Spark, the data is spread out across many missions. So when you do a group by or a join, Spark often has to move chunks of data between missions so the right rows end up next to each other. That moving around step is called a shuffle in Spark. In the context of distributed computing, shuffle is expensive. When you work with PySpark, you usually have to plan the DAG. If we don't plan it, we would shuffle data back and forth unnecessarily. It's a good practice to plan your flow before you start. Like we said before, Panda scripts are linear, where Spark is a DAG with lazy eval and planning saves shuffles. Number two is use explicit schemas. So in Pandas CSV, it guesses the types. Sometimes you fix the types later, but usually we don't do it. In Spark, we can set the attribute in first schema equal to true, and it would guess the data types. But if your data is a huge file, this step will slow down your process. It's a best practice to tell Spark upfront about the data types that you're using. So in KKBox, in our project, we knew date should be a date type and the serial number should be a string. Number three is store your data in columnar format. RK is one of the best formats to save your data when you're working in PySpark. CSVs are fine in Pandas. You just load it into the memory once, but in PySpark, CSVs are super slow. Spark is better because it's compressed, and Spark can skip unused columns. Um, so in my project, when we switched the giant user logs into Parquet, queries went from waiting forever to done in seconds. In in our chain prediction project, I saved all the intermediate results as Parquet files, and it was really fast. So number four is manage shuffles. So when we are using pandas, a group by is just rearranging data in memory. In PySpark, a group by or join means data gets shipped between computers. That's shuffle, and it's expensive. We already mentioned this process. So when we in KKBox, when we did group by serial number, and when we aggregated the number 25 column, Spark shuffled all players for the same user into one place. Knowing this, we filtered by date before grouping. So Spark had less data to shuffle. Spark lets you set partitions so you are not oversplitting tiny tasks. So another best practice is doing the light stuff first, doing the light transformations before the wider transformations. So in our case, before we aggregated, we dropped unused columns when we weren't using them. So just reduce the data Spark shuffles beforehand. So in pandas, caching doesn't really matter because we are holding everything in memory. In PySpark, you can cache or persist a data frame, but if you overdo it, memory explodes. So you should be doing it carefully. If you're planning to reuse a data frame, you should cache it. We cache the daily play counts before we use them in multiple feature calculations, but we unpersisted them from training that kept cluster memory happy. Next best practice we should learn is use window functions for momentum. In pandas, dot jolly is easy for 70 stats. In PySpark, Windows let you do the same but at a scale. In KKBox, we used listening activity in the past 7 and 30 days. How many days active in those windows? Unique tracks in 30 days, plays in 7 and 30 days, lag features, and deltas. That feature helped capture churn signals. Users whose recent plays dropped below the community average were more likely to churn. So next one is choose the right drawing strategy while using PySpark. In pandas merge is straightforward, just slower on big data. In PySpark, joins can blow up if tables are huge. So what should we do? Broadcast join for small tables. We joined member demographics with user logs. Broadcasting small member table avoided a huge shuffle in the situation. So what's broadcasting? Normally, when Spark does a join, it has to shuffle rows around between missions so that the rows with the same key, like our serial number in our KKBox dataset, end up together. That shuffle is expensive, as we already mentioned. But if one of the tables is tiny, you don't need to move the big one. Instead, Spark just makes a copy of the small table and sends it to every machine. Now, each machine can do the join locally with its chunk of the table. That's called broadcasting. So, in our case, members table or member demographics was a small table, a few million rows. Big table was user logs. We had hundreds of millions of records. So if we did not use the broadcasting function, it would shuffle both tables, which is actually super slow. By broadcasting the small member table, Spark sends a copy of it to each workers. So every worker could match our serial number against its local chunk of user logs. It's much faster and there is no giant shuffle. Next one, avoid Python UDFs. In Pandas, custom functions with apply are fine. In PySpark, Python UDFs are slow. Spark has to leave its optimized engine to run Python code. In our case, we used when and call from built-in functions. So if you don't know what a UDF is, it's just a acronym for user-defined function. It tells Spark, hey, here's a custom function. Please run this on my data. In Pandas, we do that all the time using .apply method with the custom built-in function. Since everything is in memory, when we are using Pandas, it just works. But in PySpark, a UDF is the same idea, but Spark has to take your code, send it to each worker, run it row by row. That's extremely slower than Spark's build function. So if unless it's extremely necessary, avoid using UDFs. Another big point is Do leak-free chain test splits, which is something that we missed in our original chain prediction project. In pandas, you might just do chain equal to df dot date less than a particular date as a cutoff date. In PySpark, if you aggregate first and be split by date before making feature. That way, the train set only saw behavior up to January and the test set only saw February onwards. It's not just a PySpark thing, it happens in pandas too. You should be really careful when you deal with time series data. The only difference is that Spark mistake is much more costly because we will have to do it from the initial point. It's just expensive. So in next one is while using PySpark, make sure to use the uh, PySpark ML pipeline for transformation. In pandas, if you're using pandas, we usually use scikit-learn and we can use pipeline to chain processing models. PySpark has the same kind of tools with string indexer, vector assembler, etc. In KKBox, we could index categorical columns, assemble numerical features, train a gradient boosted tree, all inside one pipeline. This one we could easily apply the exact same steps to both train and test data. So make sure to use ML pipelines. Last tip, write clean outputs. Always use Parquet and partitions. Usually in pandas we use pickle and CSV. When using PySpark, use Parquet, it's faster. And when you're writing your data in as a Parquet file, it should partition it by date. It is useful. So there's a bonus best practice. It's called Medallion architecture. So usually in PySpark projects, we save the data in three separate folders. Bronze folder will have the raw logs, usually your CSVs, the cleaned join logs, intermediate results, all of those things goes into the silver folder, and the gold folder will have the final features, the filtered clean data that we'll be using for modeling. So it's more like a production engineering architecture thing. It's a best practice.